When we talk about distributions and statistics, they can range from super simple to super complex. We're going to talk about a super simple one today, the continuous uniform distribution. And then we're going to talk about probably the one that you've heard the name of before at some point or some reference to it, because it's likely one of the most popular culture recognized distributions and statistics, and that's the normal distribution. Sometimes we talk about a bell curve. That's the normal distribution. So we're going to take a look at a couple of characteristics of these two distributions today, and we'll be working more with them in the future. The first distribution we're talking about is the continuous uniform distribution. So for the continuous uniform distribution, we have a density function for a continuous uniform random variable on an interval, a closed interval from a to b. And this density function is 1 over b minus a over that entire interval. So what this results in, if we graph this density function, is just a horizontal line between the value of a and b for our random variable. So if we imagine lines, vertical lines at a and b, then we can see that this is actually a rectangle. And thinking about continuous functions and the area underneath of continuous functions, we know that the area underneath of this horizontal line must in fact be 1, since we're dealing with a probability distribution. So if you ever forget what the density function is, you can just remember that the uniform distribution stays the same for all of the values between a and b. So it makes a rectangle, and the area of that rectangle has to be 1. So then you can figure out, you know that the base of your rectangle is b minus a. And so you can figure out that the height must in fact be 1 over that in order for the entire area to equal 1. Now, also, since it's the same value for all of the values between a and b, when we go to find the mean, we really are looking for the value exactly halfway between a and b. So to find that, we add a and b together and divide by 2. So finding the mean of the uniform distribution is also a very straightforward thing and easy to remember. The variance is a little bit more challenging, but not a ton. So to find the variance, we're going to take the difference between b and a, we're going to square it, and we're going to divide by 12. Our second distribution is the normal distribution. So the density of the normal distribution is a very much so more complex formula for us. So we find it by taking 1 divided by the square root of 2 times pi times the standard deviation of this normal random variable. And then we multiply that times e to the negative 1 divided by 2 times the variance of our normal random variable times the quantity x minus the mean of our normal random variable squared. So notice, once we know the standard deviation and variance, one or the other, and the mean of our normal random variable, then the distribution of our normal random variable is completely determined. So this distribution, while the density function is super complicated to write out, the picture that it creates is actually this bell-shaped function that never quite gets to the horizontal axis. It goes on and on forever towards infinity and negative infinity, never quite touching that horizontal axis. Its highest point above the axis, above the horizontal axis, occurs at the value that is the mean, and that highest point is called the mode. The curve is completely symmetric about a vertical axis that we can imagine being through the mean. It has points of inflection if we look 1 standard deviation away from the mean to the left and to the right of the mean, then we can see where its points of inflection are. It's concave downward if we're between the mean minus the one standard deviation and the mean plus one standard deviation, and everywhere else it's concave up. That horizontal axis, because we get really, really close to it without ever touching it, it acts as an asymptote for the curve. And this curve, despite going from negative infinity to infinity, the area under the curve is equal to 1. It is a probability distribution.